Hello, this is Hydrotech, 13th of July 2015. What I've got here is a short video to show the procedure that I follow when I create the cores for my Muller Motor tests. The cores are simply made up of a mixture of magnetite and epoxy resin. Here we have the magnetite, a clamp, plastic mixing bowl, a crude but effective measuring device whose internal volume is the same as 75% of the overall volume of the end result. The syringe is used to measure out 2.5 milliliters of epoxy resin hardener, and the knife is used to stir the mixture and help separate the components of the mold later on. The plastic is used to compact the contents of the mold, and I can't stress enough how important that is. The toothbrush is used to clean up the mess afterwards, and the Stanley knife is used to help separate the contents of the mold later on as well. The watch is simply used to help time the different parts of the overall procedure. The candle wax is used to line the internal surfaces of the mold. And finally, the measuring vessel is used to measure out 10 milliliters of epoxy resin. More about the mold. It's really an electromagnet. It's made from a single piece of aluminium bar, round aluminium bar. The overall length is 63 millimeters and the outside diameter is 37 millimeters. It has a hole drilled throughout its length whose diameter is 20 millimeters. The outside, well, along the outside of the main mold body, a recess has been machined which is 5 millimeters deep, and that houses a bifiller wound coil with 420 turns across 7 layers. I followed the Tesla's patent for a bifiller wound coil. End caps have been machined to match the main mold body, which fit as we see here. There is a difference between this diameter shown here on each end cap and that of the internal diameter of the main mold body. The whole point behind that small difference, 0.5 millimeters, is to allow for a gap to exist, and that is used as an avenue of escape for the contents of the mold once a given temperature and pressure have been reached. Beyond that point, the viscosity of the contents of the mold is such that no further evacuation is possible. Up to that point, the viscosity of the contents of the mold changes with temperature and pressure. The internal surfaces, in other words, the mating surfaces of the entire mold, are pre-waxed in order to aid the release of the contents and the separation of the component parts of the mold. I do try to eke out as much of the measured 10 millimeters of resin as possible in order to try and attain some level of consistency in terms of mixture ratios from one core to the next, because they will impact that previously mentioned temperature and internal pressure combination and resulting escape of the contents of the mold depending on the viscosity as it changes. A bit of a balancing act, if you will, but consistency in mixing ratios will result in a more or less consistent temperature pressure combination later on during the process. Now I'll measure out 2.5 milliliters of the epoxy resin hardener and mix in accordance, therefore thoroughly, Now we'll start placing the mixture into the main mold body. A good thing about this mixture is that you can't exactly spill it. Compacting is very important, as I alluded to earlier. Here we just need to give it a bit of a wipe. Compacting, of course, ensures or tries to ensure that no air pockets are introduced into the mixture. You'll notice that we can't completely compress it by hand, and that's what the clamp is for. We don't need to go crazy with the clamp pressure. The idea is for it to keep the mold end caps in place. If it was too tight, the space would be reduced to such a point that too high an internal pressure buildup would be required for the release of the contents during the low viscosity period, specifically during the first 1.5 to 3 minutes of the curing process. During the first 1.5 to 3 minutes of the curing process, 10 volts at 15 amps will be applied to the coil. The external temperature of the mold should rise to about 80 and 85 degrees centigrade. During this time, the viscosity of the mixture is rapidly changing, and it will eventually seep through the gaps between the main mold body and mold end caps. However, due to a combination of temperature change and internal pressure buildup, alongside the fact that the viscosity is still changing even further, and thus the mixture becomes even thicker, that same mixture will eventually cease with its ability to escape through the gaps any further. Therefore, a form of internal balance has been reached, and curing progresses from that point onwards. Then, for 0.5 volts at about 6 amps will be applied to the coil for a further hour, at the end of which the external temperature of the mold should have risen to about 102 degrees centigrade. This is the main part of the curing process. The contents will harden. Here we see that the temperature is indeed over 100 degrees, and it's time to turn off the power and start releasing the contents of the mold. It's important to realize the initial temperature of the mold should be around room temperature in order to maximize the length of time 150 watts can be applied to it without unduly cooling its contents. This forms the basis for the time constraints during the first stage of the curing process, which primarily serve to protect the coil windings themselves. I apply wax to the hot components of the mold while they are hot, so they are correctly wetted and ready for the next core. This is just a crude test to see if the mold, which as I said is really an electromagnet, has done its job and affected the magnetic domains of the core. And that's it.